Alright, so today we're going to talk about how to write equations of lines using our parallel and perpendicular line concepts. So first, to write an equation of a line, you need first the slope of that line and the coordinate points. You can plug these into either your slope-intercept form and solve for the b value, and then write your equation as y equals mx plus b, or you can plug it directly into point-slope form, which is what I will be doing, and solving for y from there. It's your choice. So we want to write the equation of a line in slope-intercept form. Here's our 2 points. So we need to find our slope. So we find our slope by doing the y's minus y over x minus the x. We get 4 over 2, which is 2. Now it doesn't matter which point you use, both will give you the exact same equation. Just pick the one that's a little bit easier. In this case, this point is easier because of the 0. So if I plug into y minus y1 equals m times x minus x1, it'd be y minus 3 equals 2 times x minus 0, which is y minus 3 equals 2x. So when I add the 3 to both sides, y equals 2x plus 3. So that would be the equation of the line using these 2 points, 0, 3, and negative 2, negative 1. So that's generally how you write any equation line. You'll be given your 2 points, find your slope, write your equation. Very trivial. It gets more interesting in this case right here. Notice your y values are both the same. So if you remember from last time, if I find my slope, you'll find your slope when the y values are both the same to be 0. So what this is going to tell us, it's a horizontal line, and anytime you have a horizontal line, your equation will always be y equals whatever the shared y coordinate is. If they're both 5s, it's y equals 5, and you're done. Have they both been negative 2s, it'd be y equals negative 2. Both 9s, y equals 9, whatever it turns out to be. Same concept here. Notice we have the x's are both the same. So again, we first find our slope. So the y minus the y over x minus the other x. We get 7 over 0, which is an undefined slope. Whenever your x-coordinates are both the same, your slope is undefined, your equation will always be x equals the shared x-coordinates. That's the equation, the vertical line for this particular situation. So if the x's are both 7s, it'd be x equals 7. Both negative 10s, x equals negative 10. Whatever they both are, that's the equation of your line. So those are your 2 special situations. When the slope is 0, it's y equals the y-coordinate. When the slope is undefined, it's x equals whatever the x-coordinate is. If it's neither one of those, you have an actual number, you go through the process like the first example. Now, if I want to write the equation of a line that's parallel and perpendicular to a given line through a given point, I need to first identify, well, what is my slope of this line? So my slope is negative 2. Well, I need to remember parallel lines have the same slope. Perpendicular lines are negative reciprocals. So from a parallel equation, my slope is negative 2. My perpendicular, my slope is a half. So parallel first. We plug into y minus y1 equals m times x minus x1. So y minus 2 equals negative 2 times x minus 3. We get y minus 2 equals negative 2x plus 6. When I add 2 to both sides, y equals negative 2x plus 8. Very easy. Perpendicular. So again, we just plug in the slope and the point into our point-slope form. So y minus 2 equals 1/2 x minus 3. Now for these particular problems, if you notice, if you were to distribute the 1/2 into the problem, the 1/2 does not go into the 3 nicely. So there's 2 different ways you can go about doing this. You still can go ahead and distribute the 1/2. You get y minus 2 equals 1/2 x minus 3/2. Add 2 to both sides, which we're doing 3/2 plus 2, that's the same thing as 3/2 plus 4/2. Was a negative 3/2, which is 1/2. So you get y equals 1/2 x plus a half. Perfectly fine to write it like that. The other option is to write it into standard form, meaning you're going to clear out the fraction by multiplying everything by that denominator. Meaning you get 2y minus 2 equals x minus 3. And then we move the x over. Negative x plus 2y minus 2 equals negative 3. Add the 2 to both sides. Negative x plus 2y equals negative 1. So those are your two choices. And then the same choice for rewriting in parallel lines as well. I only really recommend writing in standard form if your slope will not go into the x coordinate nicely. Negative 2 times negative 3 is positive 6, no big deal. 1/2 times negative 3, it's a fraction, kind of a big deal. Had this been like 1/3, I would have left it in slope-intercept form, like this, because 1/3 times negative 3 would have worked out nicely. Ultimately, it's your call. Let's take a look at this one. We have y equals 4x minus 5. Our coordinate points are negative 1 and 5. So our slope is 4, meaning my parallel slope is 4. My perpendicular slope is a negative 1/4. So for parallel, we'll have y minus 5 equals 4 times x minus a negative 1, which just becomes x plus 1. So when I distribute my 4 to everything, we get 1 y minus 5 equals 4x plus 4. So I add 5 to both sides. My parallel line through that point would be y equals 4x plus 9. That's my parallel line. Perpendicular. So same setup, y minus 5 equals now negative 1/4 of x plus 1. We know it's going to be x plus 1 because of the whole minus and negative from the previous problem. Everything should be the same for both parallel and perpendicular, except we'll have a different slope on the outside. I notice my negative 1/4 will not go into the 1 nicely, so I'm going to multiply everything by a negative 4 to clear out the fraction and get rid of the negative sign. This gives me negative 4y plus 20 equals just x plus 1. Please be careful. If you had still a number up top, like there was a 2 here, you would have to distribute the 2 to the x and the 1, so don't forget about that. All we're doing is getting rid of the fraction, leaving only the numerator behind. And since we're multiplying by negative 4, the only numerator left behind is 1, so it's really just the x plus 1. So watch out for future problems. So we subtract x from both sides. We get negative x minus 4y plus 20 equals 1. So we subtract 20 from both sides. We get negative x minus 4y equals negative 19. We have negatives everywhere, so quite honestly, let's divide everything by a negative 1 to get x plus 4y equals positive 19. And there's our equation in slope in standard form. Had you distributed the negative 1/4 to everything, you would then have to add 5 to it, and you'd have a slightly different answer. No big deal if that's the route you went. So why don't you go and work out this problem on your own. Go get your answers for problem when parallel and perpendicular to that given line through that given point, and I'll provide the answers for you in a little bit. Alright, when you work it out, you'll find your parallel line equation should be y equals 3/2 of x plus 13. Your perpendicular equation should be y equals negative 2/3 of x. There is no other number, it's essentially plus 0. Alright, so those are writing your equations of lines for parallel and perpendicular lines. That is it for this chapter. I will see you next time when we talk about triangles and their properties and proofs involving triangles.